Okay, so we'll start today with introduction to Erlang. So basically, what is Erlang and why is it used for concurrent programming? So Erlang is it's a new programming language and it was designed for programming concurrent, real-time, distributed, fault-tolerant systems. So we talked about what is concurrent, we talked about real-time, distributed, and what is fault-tolerant systems also. Okay, so these are the programming techniques for programming concurrent real-time systems that we have, and there are many such systems which we use in real life which require this concurrency control. And this is the typical property. Concurrency is the typical property of real-time control problems. So there are various other languages also which is used for achieving concurrency, and we have also seen some programs in the previous lectures where we used Python as a language to program concurrency. So basically Erlang is very good at using concurrent for designing concurrent real-time systems. So here we'll go through the introduction, the basics of sequential programming, concurrent programming, and distributed programming. So these are the four different types of languages that we'll be learning about. So coming to the definition of Erlang. So it is named after the mathematician Agner Erlang, and it was originally from Ericsson. So that is why maybe Erlang actually stands for Ericsson language, and that ER from Ericsson and language from Lang. So that makes Erlang. And initially it was used for telecommunication sector, and where it was a huge network where a lot of concurrent things was happening. So telecom was the first application of Erlang language, and then finally in 1998 it was open source. So it's an open source language and it is popular for concurrent programming. So what is Erlang for? So Erlang is basically used for concurrent, real-time and distributed fault-tolerant systems. So what do we mean by the declarative statements, or what are the Erlang highlights? So we'll talk about declarative statements, then what is concurrency, what is robustness, and what is distribution. So declarative means we are talking about the high abstraction level, dynamic data typing, single assignment variable, pattern matching, and real-time garbage collection. So what do you mean by declarative? Declarative means a program that specifies what is to be done rather than how it is to be done. Okay, and pattern matching is usually used for assigning values to variables and for controlling the flow of the program. And Erlang is basically a single assignment language, which means that once a variable has been assigned a value, the value can never be changed. Keep this in mind. Single assignment variable. So it's basically once a variable has been assigned a value, the value can never be changed. And pattern matching, it is used to match patterns with the terms. Now, if a pattern and the term have the same shape, then the match will succeed, and any other variables occurring in the pattern will be bound to the data structures which occur in the corresponding position in the term. Now, what is this term and what is this pattern? We'll understand what is this. We know what is concurrency, running multiple things simultaneously at the same time. So we can run the modules that are independent of each other in a concurrent manner, or probably in a parallel fashion. But now in this we have a single core. So in case of parallel we have multiple cores. So here when we are doing concurrency, we are talking about a single core and running the task in an interleaved fashion. Then robustness is how robust your system is or your program is to failures. Failures could be any type of failures. It could be system failure, it could be power failure, it could be any failure. And distribution is how can Erlang, like these programs, can you distribute it on multiple platforms rather, or on multiple machines? So these are certain Erlang highlights. Then we talk about the Erlang shell. So after you do the installation, you can just open the Erlang shell, and this is the previous version that was used, that is Erlang shell v11 was the version. And these are certain maybe these are certain commands, basic commands, which you can just type on the command prompt and try running it. So you have this pwd to get the password. Cd is the change directory command. Okay, so after you change directory, you can use the pwd command and see whether you are really into that particular directory. And then these are certain commands. C demo, I'll show you. You just remember these commands. I'll show you how it is executed in the command prompt directly tomorrow. So date and halt. So these are some basic functions which we will be using. And then before we actually jump into learning concurrency or concurrent programming in Erlang, I think we should be familiar with the sequential Erlang first. So for sequential Erlang, these are the four different you call them as data types or something. So numbers, so we have integers from 1 to minus 10, then we have floats from 3.1415 to minus 0.23, and we have hexadecimal numbers, which is base 16. So you need to represent in this particular manner. So you have the base which represents here. So if you want to represent a hexadecimal number, you have to write it in this fashion. So 16, so forget about this. Now if you write 16, the Erlang compiler knows that it is a hexadecimal number, followed by hash and followed by the number itself. Similarly, if it's a binary number system that you're following, then it has to be preceded by a 2 followed by hash and then the binary number. If it is an ASCII value, you need to precede it with the $A, and when it is $A, it means it is representing 65. So 65 is the ASCII value for capital A. If it's a small z and you precede it with the $, it will give you the ASCII value of that particular alphabet. Okay, then we come to what is called as atoms. Now this is also a very important feature of sequential Erlang. Now when you specify atoms, means it is basically a string. Hello, how are you? I am fine. You write it in single quotes or you can have underscores in between. So all these will represent an atom. And variable is just like any other variable that we have, count, sum, any of these variables. But now one important characteristics of Erlang related to variables is that the values cannot be changed once you bound it. Only it can be bounded once. Any variable can be bound only once. So once you give some value to that variable, that value cannot be changed. And then you have certain operators like plus, minus, star, slash, less than, greater than, less than, equal to, not equal to, and so on. So these are certain operators that we'll be using. Okay, I'm not going into deep of Erlang, okay, because these are just the basic things which will be explained. Erlang has to be studied on your own. You have to do the self-study and try to investigate more details about Erlang. This is just a glimpse of Erlang because our course is concurrency programming and we are not going to learn Erlang, but this has to be done side by side. So maybe today and tomorrow I'll give some lectures on Erlang. After that you need to practice it on yourself. So there are certain data structures just as we have in Python. There are tuples, list and combinations. So these are widely used. So and we'll be using these when we are writing concurrent programming. Tuples are basically nothing but like sets. So they're enclosed in curly brackets. So you have this. So this is also a tuple, a single empty set. Like this is an empty set which is also a tuple. So in this tuple you can have another tuple. So nested tuples. So this talks about tuples, nested tuples. Either if it's a number, you write it as just 1, 2, 3. A single word can be written as this, or if you want to enclose it in single quotes, that is also fine. Or if you can have nested tuples in this particular manner. So this is the syntax that it follows. Then we have list. List is in square brackets. So just as we have tuples, we have list. Similarly, so list is basically one string after the other. So this is a string. You can have an empty list also, or you can have an empty string, or you can enclose it in double quotes also. And combination is basically nothing but combination of both list and tuples. So this is a list. This signifies a list, but in the list you can have tuples as well. So this is how it represents. Okay, or you have a tuple and in the tuple you have a list. So this is a just remember the syntax of a tuple, list and combinations. So how do you bind variables to values first? So now a is a variable and binding 10 to it. So this means that it's an integer variable. So you don't have to particularly define this particular variables, but whatever value goes into that variable will define its data type, right? So this is actually we are doing the pattern matching of a variable to whatever value it is holding. Now this is what is curly bracket. We have seen in the earlier slide. What is this representing? Curly bracket is a tuple. So this is a tuple with three variables b, c and d, and it is taking these values. So see here, in a tuple you can have numeric as well as float values. So there is no a mixture of data types is allowed, or you can have this for that matter a and b. Now this a value is abc repeated twice, so it's not even unique. It can be repeated, the variables can be repeated, here also it is repeated, but now in this case this type of assignment is not allowed. Can you give me the reason for this now? See, I have a b here with the values abc and this. Now I have aab, now I'm redefining it with abc def 1 2 3, but this is not allowed. Can you give me the reason why?
A has two different values.
Pardon?
A has two different values.
So should it be allowed or no?
We shouldn't allow it.
Why? Give me a proper reason for that.
Hello.
Yes.
Ma'am, A is assigned integer number, but instead B is have integer number.
No,
Yes.
no, no.
Because we can bound one only once.
Yes, I gave you that reason, right? Okay, once the variables are bound, you cannot change the values. See this. Where did I make that statement? Yeah, value cannot be changed once it is bound. So now in this example, when I'm saying that A holds the value ABC, this is valid because A is already, this is repeating, right? So ABC, ABC. So A now has the value ABC and only ABC will contain in that particular variable. So now if you're trying to change this value, it will give you an error because it has to be ABC. You cannot change it. Neither this, because B has the value of this. Now, if you feel that these are sequential statements one after the other, so this will not be allowed because both A and B values you are changing here. That is why it will give you an error here. Now, next you are saying ABC is 1 to 3 and then ABCD is 1 to 3. So, this D is additional which is not defined earlier. So, it will not give, it will obviously give you an error here. Now, this is a comma B or C, right? So if it is A comma B or C, then you have 1 2 3 4 5 6 7. Suppose this is a now this is a list. Okay, square bracket means it's a list, and this is A or B. So this is ABC. Can you see the difference in this assignment and this assignment here? Notice the change in these two assignments and tell me what is the difference here. Come on, tell me. What is the difference? And then you're redefining again a slash b here. which cannot be done because it is already holding this value here. Or probably we can get back into other slide, and that then you can give me the answer. And there are certain punctuations which are used. So Erlang is quite a different language than the other programming languages that you use. So comma is and, semicolon is or, and dot is end. So these are the notations that it follows. For example, suppose factorial of 0. Okay, you are writing factorial of 0. So 5 factorial of 0 is 1. So semicolon is, now this is or, semicolon is or. So either you find factorial of 0, which is 1, or what you do is you find factorial of n. And what is factorial of n? N, I'll explain just. So there is some syntax which is used here. So if it is just factorial of any number 0, it is going to give you 1. So you have two options here. Either it is 0, you give the answer as 1, or you try to find what is a factorial of that number. So now this n can be 1 to any number, because 0 we have already taken care of. So 0 is 1 or factorial of n, and how to find that we'll see that later. But just try to understand what is the meaning of this semicolon here. So this semicolon is nothing but or, and this percent sign is actually used for commenting, right? So every language has got a different commenting symbol. So a program is a set of function similar to algebraic functions. So whenever you write a program in Erlang, like I'm talking about Erlang program, so it's basically a set of functions similar to any algebraic functions which behave by working only on the input values and giving the output results. So strict analogy with algebra, this we don't have. So we don't have global variables or for and while constructs. We use recursion and if and cased constructs. So switch case, which is there in C language. So these are all constructs or control statements which we can use for multiple function clauses. So now this is the formula, a simple way to understand what it is. So if it's a 0 factorial, answer is 1. So this is mathematically I am representing it first. If it is n factorial, it has to be n into n minus 1 factorial for all n greater than, strictly greater than 0. So where n value can begin from 1 to n, so which I showed in the earlier slide. So 0 factorial is 1 and n factorial is going to be n into n minus 1 factorial. So now this definition of mathematical formulation, it does not contain either cycles, for or if statements. Does it contain? It does not have any if statement. So how do you know what is the value of n, or how many times this is going to get repeated? So can we implement it exactly as is? Like just as what we have written in mathematical formulation, can we use the same thing in Erlang? So that part is very important. So let's write the first function, which is factorial. Now when you're writing the similar factorial function in C language, what you'll write? Int fact, you'll pass an argument int n, and if n is 0, you return 1. Else what you do? Return n into fact of n minus 1. So you're calling a recursive call to fact here. And this will repeat, right? And what till where? If n is equal to 0, it is going to do this. Else it will go into this. So it's going to go into the loop till n becomes either 0 or it is, and it will go into this statement if n is a non-zero value. So this is how it will repeat. So this is solutions in C using if statement. Now similar thing we can do it using while statement also. So this is another representation of the same factorial function using while. So how do you how do you write the solution in Erlang? So this is what we had written. Factorial of 0 is 1. Factorial of n is going to be n into fact of n minus 1. So can we write the same thing, because this was the mathematical formulation, right? So this was the, yeah. Can we implement it exactly as it, exactly what is written in the mathematical formulation? So these are the two statements that we write in Erlang, just as we have two statements in mathematical formulation. Else if you see the C line code, It is like you have to write multiple statements for that. But in Erlang, you can, write a very compact and an efficient program. So this is, we'll just try to understand what this is. So we had written fact of 0 is 1 and fact of n is n into fact of n minus 1. So this fact is the function name. It is defined using two clauses. Okay, so fact is a function name which is defined using two clauses. This is the first one, this is the second one. Now fact of 0 and arrow 1. So this is how you write it for assigning it. So the first clause executed when the argument is 0. So we have seen that this argument is 0. The definition is terminated with the symbol semicolon. It means that the other clauses will follow. So it is this or semicolon is or this. And then you have a full stop here. Take care of this full stop. Full stop is end. Now fact of n is n into fact of n minus 1. This is the second clause. We will not call it as a statement or a programming line. We call it as a clause in Erlang. So second clause is going to be executed when the condition on the first clause is not met. That is when the argument is non-zero. Now the definition ends with a symbol dot, meaning that this is the last clause of the function. So if you had one more clause, then you had a semicolon here and then one more to just say that this is the end of it. Full stop is going to mark the end of it. Now the function names and the language keywords are literal symbols starting with lowercase always. So you see all the function names, this is a lowercase. But in some cases, in some programming languages, we need to write the function names with a camel case. That is, the first character has to be capital. So function names and language keywords are literal symbols starting with lowercase. That is why they are called as literals, right? So you write this as lowercase letters which are called as literals. And then you have variables and parameter. They are literal symbols starting with uppercase. So if we are specifying variables, now n is a variable here. So this is in uppercase. Or even the parameter. So here this is a parameter that I am passing to this function. So all parameters and variables that you use is going to be uppercase characters. Function name and language keywords are going to be lowercase. Now this symbol, this arrow symbol here, it separates the function definition from the function body. So this is the function name separated by the function body. So this is the function body. So whatever you write after the function is the function body. So it's just the separation line. You have to use the arrow. Now the function or the clause body contains a set of expressions which are separated, comma separated. Now here we have just one expression. So if you write a function with multiple expressions, you have to separate them with comma. And then which are evaluated in sequence. So one after the other, the statements or the expressions will be evaluated. And the value of the last expression is the return value of the function or clause. So the last expression, generally which is terminated by dot, gives you the return value. So this is now what, now this is a question, this is the code that we had written in Erlang. Now the question is, what does it happen if we invoke the function -3? So now what is the value of n? N is -3. Just go through the slide and try to understand what will happen when we are doing -3, fact of -3.
It loop forever.
Huh?
It loop infinite time. It will call infinite time the recursion.
See, just execute. No? This is the function. It is not 0. So it will be fact of -3 is equal to -3 into fact of -4. This is -3 -1. So this becomes -4. Now next time what will happen? This will go on evaluating till this value is becoming 0, right? So again fact of -3 is -3 into -4 into fact of -5 and so on. So will this terminate? So the execution is not going to terminate because this value is never going to be 0. So the program has an error, right? So only these two statements is not going to take care of all the positive and negative values of n. So this program has an error since the value of factorial is not defined for n less than 0. So this check is not present in our program. So we need to do that. So how to do that? So let's look at the mathematical formulation once again. So this is what we had written. So we must add the condition for n greater than 0. So factorial of this is this, factorial of n when n is greater than 0 is going to be this. Otherwise it's not going to work because this condition is basically for n greater than 0, right? And this condition which we had written in the mathematical formula was not written in the program that we had written. We didn't have any condition here where n is greater than 0. So we need to add this. So fact of n when n greater than 0 is this, n into fact of n minus 1. So you need to learn the syntax of the language, okay? Now the statement when plus Boolean expression after the function is called as a guard. Okay, so this part, this is the function. Whatever you write after the function declaration, when followed by this Boolean expression, this is a Boolean expression, right, is called as a guard. So this when plus n greater than 0 expression is called as a guard. So this guard activates the clause if and only if the Boolean expression evaluates to true. So when is this guard going to get activated? When this Boolean expression is true. If it is false, it is not going to get executed. So the guard activates only when the Boolean expression is true. Okay. So what is this? Now we have a revised code here, right? So fact of n, when n is greater than 0, we are going to use this particular condition here. Now first clause is executed when the argument is 0, that is this. Second clause is true when the argument is greater than 0. So because of this clause here, because of the guard that we have added here. So what about factorial of minus 3 now? Can we execute this? No, because there is no clause is met and a runtime error or an exception is raised, undefined function clause. Because we don't have a function clause, we have only for a 0 and a positive value of n. We have not included any clause with a negative value. So there's no clause for that. So we'll get a runtime error if you give n value as minus 3 or any any negative number. You get the error as an undefined function clause. So what is our aim now? So a program crash is expected since the function is not defined for negative arguments. So write the clauses for the following program. So here I have left this as an exercise. So you try to find out what will be the clause for the negative number. Now this is the program where you have to write the clause for finding the sum of first n even numbers. I'll give you 10 minutes for this and I want you to do this, please. Write the clause. Now you know how we have written the clause for factorial of the program. So now the problem is for finding the sum of first n even numbers, you find the clause. I'll pause for 10 minutes. I want the clauses from you. You can do it or you can post it in the chat. Yes, any answers? Sum of n is n into n plus 1. Mahesh and Lalita giving me some answers. What about others? Only one clause is sufficient for this, just as we had written for factorial. Factorial had two clauses. So to find sum of n numbers, we just need one clause. Sum of 0 is 0. Sum of n is when n mod 2 is equal to 0, then n plus sum of n minus 2. And what if we give an odd number? What if it is an odd number? Can you, Pankaj Raut, can you just simplify it? Your first clause is correct. Second clause says sum of n when n mod 2 is 0. So is it necessary to give us a guard here? Without guard, can you simplify it further? Because we are just checking for even number. Is it necessary to give a guard? Rest everything is correct. Sum of n, without the guard will it not work? N plus sum of n minus 2. And then it is for all n greater than 0. So that will be basically for even. And if you need to add for the odd clause, sum of odd numbers, this is for Mahesh, sum of 0 is 0 and okay, you're quite close to the answer. I'll show you for both odd and even how it is. So this is how you'll write the clause. Some like this is some function name. Now you have given it as sum, so sum of 0 is 0 and sum of n is n plus sum of n minus 2 for all n greater than 0. So this will be for even numbers, and sum of n minus 1 for all n greater than 0 for odd numbers. Simple clause. And then you can just write it in this particular manner in Erlang. So this is the mathematical representation. The blue box shows the mathematical representation, and this is the Erlang. So we just wanted to represent this in Erlang. So it will be sum of n when n mod 2 is equal to 0 and n greater than 0. Then you apply this. So this is what we wanted for the even numbers. Sum of first n even numbers. So that is what like some people had written in the class. Who had given that? Pankaj. Pankaj had mentioned that when n mod 2. So this is how you write, Pankaj. When n mod 2 is remainder. So in Erlang you don't call it as a mod, you write it as n remainder 2 if that is equal to 0 and you are going to check for n greater than 0. If both these are true, then you are going to apply this. And for odd numbers, it is when n greater than 0, strictly greater than 0. Then it is sum of pair n minus 1. So I'll give you such examples, and such questions will be there even for the test or even for the exam. So given any problem, you have to write the mathematical expression or the Erlang language statements, Erlang language clauses for those particular problems. Okay. So now we'll go into the details of Erlang list, which I already mentioned, which in square bracket. So Erlang list is an ordered set of any Erlang term. So each of these individual numbers here are called as terms. it is called as term, Erlang term in Erlang. And it is syntactically expressed as a comma separated set of elements and delimited with these square brackets. So it is separated by comma. So roughly speaking, it is basically a list in C array. So however, it's not possible to directly get the ith element. Now if we had an array, or how do you represent an array in C? So we can go na a of, if I say a of 5, it will take me to the 5th position or the 5th element of the array. But here we cannot do that. Okay, but we can separate the first element from the tail of the list. Now tail is 44 and we can separate this. So since we cannot go to a particular position in case of list as we can do in array, but we can go to the, we can separate the first element from the tail of the list. So using only this operation, the complete manipulation of the list is possible. So what is the operation possible on list is only separating the first element from the last element or from the tail of the list. And using this operation, you can try to do all the manipulation. So this is how it goes. Suppose in the list you have first, and if you write this as rest, okay, this is the list. Now first will contain the first element of the list, rest will contain the sublist. Okay, now for example, these are keywords, okay, first and rest are the keywords. So when I say first, this is a pipe sign followed by rest, and this is a list that is being defined. So what will first contain? First will contain only the first element and rest will contain 9, 15 and 44. So first and rest are the keywords. So this is the syntax. In square brackets you write first, pipe sign, rest is equal to list, full stop. And you define the list in this way, and this is how it will bifurcate. So you can just separate out the first and the rest of the elements, or you can say head and tail. Okay, so head and tail, suppose you have the list contains only one element, so head will be 16 and tail is nothing left, so it will be an empty list. Okay, so first, rest, head, tail, all are keywords which you can use in Erlang. Now if you write first and tail equal to an empty list, so this will be a runtime error. It is not possible to get the first element from an empty list. So it gives you, if you define in this particular manner, it will give you an empty list. This is the mathematical formulation for an empty list if we want to find sum of first n elements. So generally this is a formula for summation I is equal to 1 to n xi, and you add, and I is running from 1 to n, so you are going to add all these elements. So the C implementation will be, this is the sum that you define. Now this is a pointer. Now for I, and you have some result equal to 0. So because you are doing the sum operation, so result is 0. Then you are running the for loop for I is equal to 1 to n, I less than n, I plus plus. And because you are starting from 0, this will go up to n. If you start from I is equal to 1, this will go up to n, equal to n. And result is equal to result plus x of I. So x is the array. So it will just go on adding, the I value is going to change, right? X of 1, x of 0, x of 1, x of 2 up to x of n minus 1. And it will return the result. So this is the C code for writing this particular sum. Now Erlang does not have the construct to get the ith element, which we saw now, nor does it have the for statement. So we must use recursion in this case. So this is how it will look like. Sum of, if it is empty, it is going to be 0, and sum of all this is nothing but x1 plus sum of the remaining. Okay, so how we'll do it in Erlang is basically sum of empty brackets, empty list is 0, and now you are going to separate the head and tail. So it will be sum of head and tail. So that is, head will be separate. So this is what is the head, plus sum of tail, sum of remaining tail. That's it. So this is how it will give you. So in C, if you see that it's a 6-line code and 2 local variables, but Erlang solution uses only 2 lines of code. So this is first class, this is the second class. Very simple to do this. Is this understood? I hope you are understanding the concept of list. Okay, so and this is the operator that we are using, you know, this pipe sign here, which is also used to build a list. So list, first element, pipe sign, tail of the list. So it builds a list by chaining the element, first element at with the list tail of the list. So it will try to build the list. For example, x is equal to 7 pipe sign y. If this is the list and you define what is y. So what will be x then? X will be this 7 will be added and it will append these elements of the list because this is what is x. So x is 7 plus whatever is the elements of the y list. Similarly, y and z. So what is x? X is 16e, z is equal to an empty list. So how it will do this? We know what is y. Y is 9, 15, 4, 44. Now this is trying to merge y and you have the pipe sign with z. So what will happen? What will x be now? What is x? X is actually it's a hexadecimal number e, right? So basically this will be it should be 16e here because z is empty, it is not going to append anything. So it will have only this 16e. So e is basically a hexadecimal number. And then this is another example where x is equal to y pipe 1, 2, 3. So again this is a nested list. So x is 16. So what it will do? X is, this is y, this has to be y is 16. So what it will do? It will append 16 and the remaining list will be as it is. So these are this particular operator which is called as the pipe sign is used to build the list. Any doubts up to now? Okay, so we'll stop here. I'll continue with this Erlang portion tomorrow.